Hello, I'm Mrs. Daywald, and today I'm going to be doing a word problem with you that was inspired by some difficulty that students had on the last test with a problem that was similar to this. This problem incorporates both distance in a coordinate plane as well as unit rate. So it's a multi-step problem, and you need to go step by step in order to solve it. The map is drawn on a coordinate plane. The dotted line indicates the distance Joan needs to drive from home to her office. Each unit on the map represents 8 miles. If Joan drives steadily at a rate of 45 miles per hour, how long will it take her to get to work? The first thing you should do when you read a word problem is read the problem. The second thing you should do is reread the problem. So I'd like you to press pause and reread the problem to yourself and think about a strategy of how you want to solve the first step of this multi-step problem. Pause your video now. So hopefully you had some time to think about your multi-step problem. The first thing I need to do is find the points H and O on my coordinate plane. I gave you a little hint here with the point H and point O, but I'm hoping that you already have that strategy. So the first thing I want to do is find point H. I have to walk on I call it the escalator or the x-axis to the first point, H. So I'm going to move to the left to -6 and then down to the -2. So it's going to be -6, -2. And then I'm going to check it just to make sure I didn't make any mistakes. -6, -2 is point H. And then I have point O, and I have to move to the right this time. It's going to be positive because it's in the first quadrant. I'm going to move 9 and then up to +8. So +9, +8. Now those 2 points don't really help me too much because I have a turn in the middle. And I need to know this point right there. So take a minute if you haven't done it already. Press pause on your video and tell me what that point is, the extra point, the turning point. I'm going to call that the turning point because it really doesn't have a name. It's just the point where she turned at the stop sign or the traffic light. And that point, I'm going to walk on the x-axis over to -6 and then up to +8. And that point is going to be key because it's going to help me to figure out the distance between H and the turning point, and then also the distance between O and the turning point. So I'm going to use something called absolute value of my 2 points. So I'm going to take point H at -6, -2, and I'm going to take the turning point at -6 and 8. And you recall that -2 and 8 are the ones that are not the same. So I don't need the 2 that are the same. I need the 2 that are not the same. And I'm going to use the absolute value of those 2 points to find the distance between those points. Press pause and do it on your own, and then I will do it with you and make sure your work is correct. The absolute value of 8 and the absolute value of -2. Recall that since I have -2 and +8, they're going to be in different quadrants. So in different quadrants, I need to add the 2 distances in order to get the distance to the x-axis, from H to the x-axis, and then from the turning point to the x-axis. So 8 plus 2 is 10. The distance between those 2 points is 10 units. Let's pause and now do the turning point to O, point O. And then check your work with me. -6 and 8 is the turning point, and point O is 9 and 8. The same number is 8, so I'm going to use the absolute value of 9 and the absolute value of -6. And I'm going to add them since one is positive, one is negative. 9 plus 6 is going to be 15 units. So I know that my total distance that Joan travels to work is 10 units to the turning point. And then once she turns, she has to go 15 minutes to her office. So it's going to be a total of 10 units plus 15 units is going to equal 25 units. That's the first part of my problem. I did need to erase to give myself some extra room. And part one was 25 units from H to O. Sometimes students want to use the leapfrog method. Leap, leap, count, 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 count. And it tends to not be very accurate. I don't recommend that method unless you're only leapfrogging to 2 points, to 2 units. But when it's 25 units, that's pretty far and there's a lot of places to make mistakes. So part 2 of this problem is going to be, I need to figure out how many miles she travels to work. And this is going to be, I see each unit and I see 8 miles. So each unit is going to be 8 miles. So I have a miles per unit. Remember when we hear per, we think per portions. I say that kind of weirdly. It's actually proportions. So we have 8 miles to 1 unit. Press pause and fill in the other piece. The next piece of information that I know is I know she went 25 units. So the top number is going to be X. This is part 2. Now in order to solve that, I always solve proportions by cross multiplying. X is equal to 200 miles. I know that she travels 200 miles to work. So the next part is another proportion. I know that she's traveling 45 miles per hour. Go ahead, press pause, and write your proportion for that one. Hopefully you were able to press pause and you had that it was miles per hour. And the proportion should look like this. 45 miles per 1 hour. And if she traveled 200 miles, X on the bottom. I'm going to move this answer up here, and X times 45 is 45X is equal to 200. I need to isolate that variable by doing the inverse operation of division. I have 45 on the bottom. And then use a calculator. X is going to equal, it is going to be 4.44. It's going to be a repeating 4, but we're just going to round it. And that's going to be, if you go to your proportion, it's going to be hours. And I'm going to squeeze that in the bottom. Then I'm going to have to erase again and rewrite. So press pause, and then we'll be right back with you with the last step of our problem. The final part of this problem is going to be converting our hours to minutes. Now we know it's 4 hours, but I need to know how many minutes are in 0.44 or 44 hundredths of an hour. So I'm going to just round that to 44 hundredths of an hour, and I have minutes to hours, and I know that the conversion factor is 60 minutes in 1 hour, and I will need to find out how many minutes are in 44 hundredths of an hour. And I'm going to cross multiply. Press pause and type it in your calculator, and your answer would be X equals approximately 26 minutes. So my final answer is going to be 4 hours and 26, I'm going to say it's about 4 hours and 26 minutes to get to work. And that's my final answer. And you probably want to write a sentence that said it will take approximately 4 hours and 26 minutes for Joni to get to work every day. Joan to get to work. Great job, and continue to work hard and keep solving those conversion factors and proportions.